Mūsų laukia pirmoji tema. Vertimas į lietuvių kalbą skambėtų kaip valytuvai, smėlio kirmėlės ir kiti nežinomi pavojai, kaip galima panaudoti dirbtinį intelektą ir mašininį mokymąsi, kad pergudrautume savo priešą. Pranešimą skaitys vieno mūsų partnerio SentinelOne, kuris yra mūsų galva vienas pažangiausių dirbtinio intelekto ir kitų saugos priemonių diegėjas. Tai jo atstovas yra Jasper Drumpf, Šiaurės šalių regiono pardavimų vadovas. O pabaigoje dar parodysime trumpą demo. Jį pristatys Nils von Greyers, taip pat vyresnysis sistemų inžinierius iš SentinelOne. Tikiuosi, kad įžvalgos, kuriomis netrukus pasidalins pranešėjų, padės sukurti geresnę, paprastesnę ir saugesnę IT infrastruktūrą, kad jūsų organizacijos veikla pasiektų daugiau. Jasper, I made a short introduction in Lithuanian, so the stage is yours. You can start.
Yeah.
At least we understood our own names.
Thank you. Yeah, we understood our own names and SentinelOne. I think that's
pretty much that.
Yeah. So, well, thank you for that introduction, Vedas, and I think first of all, thanks for inviting us here at this event here. Happy to be here and give our perspective on this industry. Yeah, my name is Jesper. I work for SentinelOne. Obviously, I manage sales in the region and work with our partners and customers on can you say our solutions and trying to make the world safer, as they say, right? So I think you said it in the beginning, right? But the plan is to give you our perspective, a bit presentation on SentinelOne, do a short demo, and then take any questions. I think meanwhile, during the presentation, if there anything comes up, just shoot out and we'll try to answer while we are at the topic, if that's okay. Alrighty, so let me try and share my screen here. Is the sound okay? I hope you can hear me.
Yeah, Jasper, we hear you and we see you. Looks good.
Cool, and then do this one. Do you see this?
Yeah.
Good start. Okay. So again, thanks for having us here and giving our perspective on this. Of course, as the title says, Sandworm and other, can you say, threat actors out there becoming more and more advanced. How do we address this in the industry? So overall, SentinelOne's perspective is really using machine learning and artificial intelligence. That will, can you say, be a guide through this presentation. So our message overall, and not to steal all the thunder in this presentation, but that is really to take a different perspective than what we've had in the industry for so long. Because adversaries, they're getting more and more advanced, obviously. So we need a new approach. Let me first take you through, some of the things we focus on here at SentinelOne, and hopefully that gives you the perspective. And again, any questions, shoot out. We're here to have a dialogue, right? So I mentioned it a bit in the beginning here, but if you look at the industry overall, we are actually not afraid of spending money. We spend a lot of money on cybersecurity, an annual spending above quarter of $1 billion. That's quite a lot of money. Does it solve the issue? Well, not really. We still get compromised. We see threats rising. We see effectiveness decreasing. And obviously, eventually we get compromised because our resourcing to solve this issue is also flat. So our approach to this is really to try to solve that efficiency gap that is kind of positioned there on the slide deck. Furthermore, with all these spending, we still see dwell time, namely the time from we're compromised until we realize it, is extremely long. So we are hacked, so to say, without knowing it for a very long time. And of course, the digital transformation, which I think everyone is going through, is basically the accelerator for this. So this is really the issue we are trying to solve at SentinelOne. And effectiveness includes a lot of different things really in that. So let me take you through how our approach to that is. So we see more data. I think everyone knows that we have a lot of tools. It throws a lot of data and alarms at us. We deploy a lot of security tools. We get more and more of them. We have a tendency to have a kind of siloed approach, and we try to hire more people to handle these issues. These approaches and again, we've done this for a very long time in the industry. It does not really, as we say here, translate into a better outcome. And the outcome focus is really where we are at SentinelOne. We want to focus on the outcome that our technology, our services deliver to our customers. So if I take those three, items there, data. Again, we see a lot of data. What we want to do is transform that into insights. So we really, instead of just having a lot of data, which we don't really know how to handle and dive into, we want to turn those into insights, so it really makes sense, that really resonates, that pool of data that we have access to. The massive number of different tools that we deploy in our infrastructure, we want to turn that into a platform. So basically, it limits the access. For instance, a SOC analyst is using in his or her day-to-day work, just working with one platform with which access basically the tools that you have deployed. And then again, as I said, we want to make this not people independent, but basically turning people into being more efficient. So focusing on what's relevant. So to turn it into context here, which alarm is it that really makes sense in my infrastructure? I have 1,000 of alarms. Which one does really compromise me? That's where people they should focus. And then, as the title of the webinar kind of suggests, we want to do this in introducing automation. So basically, automate these different steps here. We'll show you in the next couple of slides how we want to do that. But that's really the legacy and why SentinelOne were kind of founded in the beginning, where automation were a big part of what we're introducing to the market. So again, any questions, shoot out. So this slide really shows you the evolution we as an organization has gone through. I mentioned automation a few times. In the early days when we kicked off in this industry, our ambition were basically to solve the antivirus problem. It's still around. Customers still huge, a big spending on AV, and it doesn't really solve the issue. So basically, that's our legacy. We wanted to go into our customers and say, you spend a lot of budget on having legacy AV. It doesn't solve the issue. This is a new approach. So what we did back in the days was we introduced autonomous AI in the technology. We were focused on the device. We were focused on preventing. and as it says here, reduce the device impact. So that's really our legacy, and that's also important to understand where we are today. The whole autonomous and automation approach that we took from the beginning is important for where we are today. As things evolved, the industry introduced the term EDR, basically where we are trying to solve a compromise. We use a tool, a EDR tool, to detect and respond a compromise. So that's where we moved into as well. We again introduced AI and automation, and instead of focusing on the device, our shift focused towards the incident. So of course, when you have an incident, when you have that one alarm that basically compromise your infrastructure, that's where we use the EDR technology. And then to where we are today, really, the term XDR is probably familiar to most of you. Basically, I would say that it includes all your infrastructure, so extended detection and response. So basically, including all your deployed technologies and processes in your infrastructure. That's where we are with SentinelOne today as well. And as I said earlier, we are now focusing on the outcome. And the reason for that is EDR, it's a great tool, but sometimes it's also siloed. So we need input from all your devices in the infrastructure. That gives the full picture of an incident, and it can really eventually give you that outcome that you want to have. So that's the kind of the evolution that we took and where we are today. I'm going to try to take you through this slide step by step, but overall, our platform is called Singularity XDR. So Singularity is a kind of a name that we use for our platform, and it goes across everything we deliver to the market, so to say. So basically, our overall ambition is to ingest all data that you might have into our platform and deliver the outcome that you wish. Basically, as it says in the bottom here, take you from a stage where you can see through protect and to resolve the issue that you're facing, the compromise that you're facing. And we want to take that data across your hardware platforms, across your software platforms, across your cloud instances, your mobile devices, any storage you might have, and then also, of course, your infrastructure. I have a short pitch later on an acquisition we did just recently and finalized it last week, a company called Ativo Networks, where we basically now are able to hunt in identity platforms like AD, for instance. So again, our ambition is to take all that data and throw it into our platform. We can even take from marketplace where we have many different vendors within different verticals, take data from them and throw it into our platform. Take it through what we call storyline. Storyline is I would say our claim to fame, if you will. When customers see that's where they have the aha moment. Storyline is basically a technology that looks at all incidents that happens. To give you an example, let's say that a user receives an email with an attachment, clicks on it, opens a Word document, and then through those processes gets compromised. Storyline keeps track of all these different incidents, and eventually in the storm of alarms this one compromise will generate, are able to track back and see where does that actually originate from. And then Storyline is also able to roll back and basically roll your full instance back to a stage where you were before you were compromised. So that's the in essence, you know, the technology that we built. We also add signal to it, basically intelligence feeds. We also work with different intelligence vendors. Deep visibility is a technology that basically makes the threat researcher able to hunt in the system. And STAR is part of the storyline. ISO is basically remote orchestration. Basically gives you the possibility to address all your remote devices. I remember when I joined this industry a long time ago, when customers got compromised, they had to ship laptops, you know, from one location to another physically. That can be a challenge, obviously. But with this ISO feature, we can basically address those remote units. And again, marketplace, I mentioned that in the beginning. We can still you know, share data with what you have as other, can you say, vendors' equipment. And again, the whole can you say ambition with this is to deliver the outcome that you might wish. We can deliver that on any digital service or any analog service. So introducing a platform, one platform that basically is used to handle all your incidents. So SentinelOne XDR Outcomes. When we introduce these technologies to our customers, we see that if you remember in the beginning of the presentation, the resourcing were flat. What we see is that we can you say equip people with a tool that basically makes them more effective. So we're able to follow that line up and keep you know, the organization's infrastructure clean, so to say. We are it's a bit of a bold statement, but as of today, our customers hasn't faced ransomware using our technology. That's a bold statement. It's also a statement that we, at least to some extent, has backed up with a money-back guarantee. Probably a little bit of a funny comment here, but you know what I mean. It's very, very limited of you know, customers being compromised when they use our technology. We also see the dwell time shrink a lot. I'm not going to comment on the return on investment there. That's a third-party organization doing calculations. The market trusts us. I think that's the take from this slide. We are a leader in Gartner. MITRE, for those of you who knows MITRE, they just came out with a new study. We are leading that again. We've got you know, a ton of global customers, and we also just last year IPO'd. So basically, we went public, listed as S, as it says here, on the New York Stock Exchange. A very successful IPO. So I would say the market trusts us. We're going through massive growth in the industry, and yeah, that's of course a sign that we're trusted by partners and customers. Was there a question? Nope. Okay.
No, not yet.
Okay. I put in a few slides here on you know, I talked a lot about our Singularity platform, the technology itself, which of course is in essence of what we do. But I think technology is needed. It's the center for addressing those advanced threats, absolutely. But we also need people. In our case, we have we offer what we call our vigilance platform. So basically, providing threat hunting and compromise assessments. So the ability, of course, to do that remotely for our partners and customers, but also introduce compromise assessments. So you say, of course, it's a snapshot of where you are as an organization, how we compromised or not. A very interesting service is our MDR service, so managed detection and response, which basically speaks into, can you say, very often the lack of resourcing. So basically the lack of people. We see, the market in general requiring people with these skills, and that's very difficult to get access to these people, and that's why we offer this as a can you say remote service. And last but absolutely not least, our digital forensics and incident response services. You can imagine that when we do a compromise assessment, or if we do the MDR service and discover that our client is compromised, we want to get back to normal state. That's pretty standard. So we do offer incident response as well. I think I will skip this one, and then I'll speak a little bit about the latest news that we published here. As I said earlier, SentinelOne completes acquisitions of Attivo Networks. That's very interesting acquisition we did. It was again finalized just last week. So basically, Attivo Networks is an organization that looks at identity. So it gives us the ability to add, threat hunting capabilities into specific AD in your environment. AD is very often the first place that a threat actor would look for. So Attivo has a great technology that addresses that specific issue. So with that, we are kind of expanding our portfolio. And I think that's a sign also that, the approach that we take to solve these advanced threat actors here, and that issue that comes with them, and the IPO we did, it has given us very good resources to go out and do such acquisitions. So very interesting acquisition moving forward. As I mentioned, MITRE came out with an updated look at how us vendors are doing, and we came out really well once again. I do have a link I can share later where you can take a look if you want to look at it in more specific details. But when MITRE looked at specifically Sandworm and other of those advanced malwares there, then we came out as number one. So I think we've proven ourselves, so to speak. Do you know this guy? Focus. You must. Okay. So what we say is ransomware attacks are the largest cyber threats to enterprises. So focus on that. Move away from traditional protection, which we have, used in the industry for so long. It has proven to really not work. It's just a resource and budget spender, and it doesn't really solve the issue that you're trying to solve. Use automation and AI. That's our approach to this. And then XDR, take that approach because it includes your full infrastructure in your environment. So basically, that's my feedback to you guys this morning, and a bit of a pitch on how we introduce autonomous cybersecurity with our technology.
Good. We still have no questions in the chat. So I suggest that Nils will start with the demo, and the Q&A we will do at the end of the presentation.
Perfect. Can you hear me?
Yes.
I'm Nils von Greyich, solutions engineer, so I'm the technical conscience as of Jesper. Been with SentinelOne for 4 years, kind of a veteran at this company, previously with Tanium and Fortinet, been doing Palo Alto stuff, and basically been in security for the last 20-ish years. So I'm going to try to share my screen here. Give us a second, and you can tell me if you can see my console. Is my screen sharing working?
Yeah, we see.
Oh, perfect. Good stuff. So I just want to show you some capabilities of SentinelOne and how it actually works when a machine gets breached or when an attack is detected. Some words, though, we talk a lot about automation, which is great in a production environment, but in a demo environment, it's terrible because if you block threats that quickly, you don't get anything to look at. So I actually configured my SentinelOne solution here. Let's see, for my policy to only detect an alert. This is so we can actually see the threat get executed on the machine. Otherwise, we would just immediately block it and we would have the world's shortest demo. So I've specifically configured it to allow to run on the machine fully. So the threat is actually, I'm going to do a ransomware attack, and it's actually going to ransomware the whole machine. Then we can have a look at what we detect, how we detect it, and what kind of data we can see within SentinelOne so we can manage the threat. And that's basically the only thing you configure from a security perspective. It's the 2 different threat levels, malicious and suspicious, to protect or detect. And in my case, detect. The default action would be to kill and quarantine a threat, but you can go further than that with remediate and roll back the machine also. That doesn't necessarily mean it's a good idea in production, but it's definitely a possibility. Typically, customers run in protect mode in kill quarantine, so they immediately manage the threats at machine speed. And that means when a SOC analyst is actually looking at an incident, it's already killed and removed on the machine, typical EDR systems where a detection is made and you have to make the decision what to do with it. Most often that decision would be quarantining the machine and do a reimage with all the logistics involved there. Anyways, running detect only mode, all my detection engines are enabled. The rest is operational stuff, like what do we show to the end user. Anti-tampering enabled, so we protect the agent from manipulation from attackers or system admins, for an example. So policy-wise, detect only, that's the important thing here. And we're going to jump into the incidents view. I currently have no unresolved incidents, so let's change that. So I have my problem machine here, stolen some pictures of other people's vacations, and I have this file here that I downloaded, got a link in a mail, and freebeer.exe. And as I, like most people, want free beer, I'm just going to execute it and answer yes to everything. So think of this in the context of a traditional EDR rather than XDR with autonomous responses. What EDR vendors typically mention is 1-10-60. So what they're talking about there is 1 minute until you get a detection. So that's 1 minute from something happening to you get an alert, basically. Then you have 10 minutes to start investigation of the attack, and then 60 minutes to start remediation, which basically would be quarantining the machine. So that's kind of the timeline that SOCs are used to when working with EDR systems. So 1-10-60. So I'm going to execute this freebeer.exe, which is a Tesla crypt ransomware, and I'm just going to answer yes to everything. So let's go. There we go. Yes. So we immediately had a threat detection, which we normally would block this if the policy was set to kill quarantine. In this case, it's detect only, so we're going to let it execute and do its thing on this machine. And yes, so that's how long it takes for to ransomware a typical workstation these days. So I'd say that that's less than 10 seconds. If you're going to wait 1 minute for an alert, 10 minutes to investigation, and 60 minutes to remediation, then it's way too late. The machine is already ransomware long ago. So let's have a look at what's going on here. All my files are encrypted, so that's that. I got some instructions on how to buy Bitcoins and use Tor browsers and so on. And you actually have to give it to the ransomware guys. They have a great customer service, good documentation and support. So I'm going to do one more thing here. I'm just going to open Notepad. And this is to show you how we manage threats, because it all ties down to the storyline that Jesper talked about earlier. So I just open Notepad on the side here. Am I still here? I'm going to move that to the bottom. So this is to show you that when we do manage threats, we only manage the things that was related to the detection, nothing else on the machine. So we immediately got an alert in the console. It took less than a few seconds, and we're going to investigate this. Worth noting is a ransomware running on a machine generates hundreds of detections. There is a lot we can detect in this type of event, but we only generate one alert. And the idea here is more alerts is not better. One alert with a context has a better outcome, because the SOC analyst doesn't get drowned in atomic events, but rather have context to what actually happened on the machine. So as this was one attack, the freebeer.exe, and everything it did, everything related to it, gets enveloped into the same incident. So let's jump into the incident. We can see here that we had two file detections here. Both was on write static AI. So these detections was based on machine learning detections. SentinelOne doesn't use any signatures whatsoever. There is literally no signatures in the product. So I'm going to pick up the freebeer, which was the first detection, and then I have the metadata around the attack. So where was it executed from? Desktop freebeer.exe. I have my process user. The user victim executed this on the machine, which is a local user on that machine. It's not a domain joined user. You also have threat intelligence. If you want to go out and check on recorded future or virus total, you can immediately see if this is a known bad or not. In this case, I padded this file with some data, so it gets a unique hash or a unique fingerprint, which means that a signature or a reputation service can't detect this file. The alert was initiated by the agent policy. There is the possibility and methods of creating custom alerts within the SentinelOne platform, where you can write logic rules for detection. So for an example, if source process name is PowerShell and the command line contains a base64 encoding and there is a network connection, you could automatically generate an alert. SentinelOne as a product can't do that, because in some environments that should be okay. In other environments, it shouldn't. So we also give the ability to customize our solutions for the specific need or kind of requirements for a specific part of an environment. So in this case, it was the policy. It was an autonomous detection. The agent doesn't need cloud access to do anything of this. It's basically baked in the endpoint itself. So all the detections and all the actions is taken in real time on the endpoint without actually needing a cloud connection at all. There is no data processing in the cloud for detections. The first engine that detected was on write static, so that was pre-execution when the file was written to disk. Then it went into a dynamic detection as we let it continue and run. The dynamic detections are behavioral based, so what actually happens during the execution. Our classification here is ransomware, and we give this a storyline ID also. And the storyline is fundamentally when a spawner process starts, the first process that starts in a chain of events. We give it a storyline ID, and that storyline ID is then inherited by all child processes and all their events. So we always know where something came from. And the storyline is the base on how we detect, because we detect within a storyline at all times. And you can see on the right here the threat indicators we picked up, and we might map this to the MITRE ATT&CK framework. So these are usually called TTPs. An indicator is not necessarily malicious. It's just something notable happen on the machine. So for an example, a privilege escalation, a process gaining privileges to a higher privilege level. That is something that happens on a machine natively all the time. But in the context of a detection, you probably want to know about it. And that's how indicators work. So in this case, we had a static engine detection pre-execution. We have shellcode executions. So command lines were run during this attack. It behaves like a ransomware based on the file operations. It deletes shadow copies. So it removes snapshots or local backups of files from the machine. This is typical ransomware behavior. This always happens when a ransomware run. It has persistence, in this case through autorun, so a current version run key in the Windows registry is created. It modifies startup files also for persistence. So if you reboot the machine, the malware will just restart again. Suspicious library loading, which is basically side-loading DLLs. So it's loading unrelated libraries to this binary. In this case, it's encryption libraries for the RSA 2048 encryption. We also have some evasion methods. So it hides the way it executes by code injection in this case. So it injects its code into another process memory to hide its name. It writes to hidden file sections, creates suspicious registry keys, and it adds a new root certificate for the encryption on the machine. So in this case, it's pretty clear-cut already if you're a SOC analyst. If you see things like deletion of shadow copies and encryption of files, it's most likely a ransomware. So let me jump into the storyline view, where you can actually see the execution, how it was executed on this machine. So in this case, in the whole event chain, we have over 12,000 events, and it doesn't make sense to look at 12,000 events. It just takes too much time. So the context here is extremely important. So by selecting a process, you will see the events for that specific process. So in this case, FreeBear was executed. It ran a command line, and it ran this file, vcwses.exe. So what is this? Where did it come from? It's certainly not a Windows native file. You can also see that the threat is evolving. There has happened more stuff during the time we were looking at this view, so you can reload and get more information. It's a very interactive and fast console. So back to the file. Where did it come from? Okay, so I'm at the parent process. I don't have any network connections, so it certainly wasn't downloaded. But I have 5 file events here, and one of those is a file creation of this file, app data roaming, vcwses.exe. So this is in malware language, it's called a dropper. So FreeBear is a delivery mechanism for the actual ransomware, the Tesla crypt in this case. So FreeBear drops this file, and this is polymorphic. It has a different hash and a different name every time I execute this threat, which means that it's going to be hard to detect by something signature-based or reputation-based, because the fingerprint is unique every time it executes. So it's an evasion mechanism. So FreeBear drops the payload, the malware, and executes it. After that, it runs a command line, and that command line is delete user victim desktop freebear.exe pipe null. So it drops the malware, executes it, and then it deletes itself. That's another evasion mechanism that malware typically use for avoiding detections. So think of it, if you have a signature-based solution, if you're patient 0, the first one, maybe you get a signature in 2-3 days. And when you then do your full disk scan, this file won't be on the machine anymore. So you have no idea where it came from, or that it even was on the machine at any given time, which makes investigation a lot harder. So the payload itself then, what does it do? It has over 9,000 file events, and that's just inherited on how ransomware works. So the way a ransomware encrypts a machine is it creates a new file, copies the data from the old file into memory, encrypts it in memory and writes it to the new file, and then delete the old file. So for each encryption of a file, you actually have 4 file operations: create, read, write, modify, and delete. So basically, if we slice this down by 4, we have around 2,500 encrypted files on the machine. We also had a set of network actions here, and that's the IP connections of this specific process. So basically, it's exfilling its private key on port 443. And of course, you can use this to have a look at your firewall, or if you want to search for these IP connections on other machines, you can do that within SentinelOne also to see if something else could be potentially infected. We have a registry key created by this process, and that's current version run. So that's an auto run key. We saw that in the indicators. It calls itself ADM VSS_MS, but it's just the same malware executing again if you reboot. So all my files get encrypted and the old files get deleted, and then the malware starts its cleanup phase, cleaning up the system so it can't be recovered in a good way. So consent was me clicking yes. I don't know why this version of Tetracrypt is using the user's privileges. It's pretty easy to privilege escalate without user consent. There is a process in Windows 10 called the forward on demand helper, which can always be used to gain system admin privileges on the machine without the user having that kind of privilege. So this was me clicking yes. Then we have a VSS admin, which is the Windows Shadow Copy Service admin tool. So the thing that manages snapshots on the machines, the local backups. And here you can see delete shadow all quiet. So the command line here told the machine to delete all the shadow copies on the machine, so removing the backups. We can also see that happened pretty much immediately after the initial execution. Then we have another consent, me clicking yes. We have Chrome opening, showing the restore files.html, the instructions. The same for Notepad here, restore files.txt. Another VSS admin, shadow copy, and again deleting shadow copies, but this is later in the process. So it kind of makes certain that snapshot hasn't been taken during the encryption phase. And the final step is running a command line, and that is deleting the dropper file, the vcw ses.exe pipe null. So malware drops file, encrypts, cleans up, and then deletes both FreeBeer and the dropped file. So there is literally nothing left on the malware on the machine, but the machine is fully encrypted. I hope you're with me so far. So let's take an action on this threat. So mitigation action, these are the things that is normally automated by the policy. In my case, it's detect only, so we hadn't taken action, but you can always change an action later on. So if your default action is kill quarantine on a threat, you can then manually do remediate or rollback later on that threat. So kill kills all the processes in the storyline, anything related to the attack. We do this because if we miss a detection, it's not the end of the world, because we can probably pick up a detection a little bit later, and then we will kill anything that happened before. So it makes perfect sense from a security perspective to manage it this way. It makes the solution a lot more complete. Quarantine, we quarantine the detected files and the offending file, the file that started the whole attack. So anything we detected as malicious, but also the file that initiated the attack, regardless if it was detected or not. So this is basically what your AV can do pre-execution. We can also do it after execution, as in this case. Here is kind of the magic, the remediate. So what we do here is we delete everything created during the attack on the machine. So persistence mechanism like scheduled task or registry keys, for example. Files that got dropped on the machine, like scripts, any file that was created during the attack. So it could be user login scripts, for example, but also malware files. So this basically uninstalls the malware from the machine. It kills, and then it removes all the files created by the malware. So this means no kind of recovery in the form of doing quarantining and reimaging of machines. This is literally happening at machine speed. In my case, I also had deleted files on the machine, so I want to restore those. I'm going to mark this as resolved, true positive, and call it my ransomware demo. And apply. So I now executed this action. We have a kill pending, and in a little while we're going to see how it starts to kill off the processes, clean up the system, and kind of recover the system to the state it had before the attack. This can take up to 30 seconds to execute. So I'll have to tap dance a little here while that is happening. The way it works is basically that the console instructs the machine what storyline is malicious. And there you can see now we started to killing off the process, removing everything created by the malware. And the last stage is to restore the machine back to the state it had before the attack. So we're not really that worried about ransomware attacks when running SentinelOne. It's, even if it's not detected, you can still mark it as malicious and roll it back at a later stage. Worth noting here is everything is back. My malware here, the freebeer.exe, is quarantined and gone, of course. All my files are back, and the machine is back in the state it had. But we did not touch the notepad I opened here, because that is a part of a different storyline. So if the machine is doing something other during the time, like a user is editing a lot of documents, or it's a system that produces something that needs to be up 24/7, we can still manage that without interfering with anything else on the machine. We only manage things that are related to the specific attack, which makes it a very low impactful thing to do on a machine. There's literally no downtime for the system. Any questions on this so far? I can't see the chat, so I have to ask you guys. Do we have any questions?
No, we still have no question, but
right.
I have one.
All right, go.
So can the initial protection from SentinelOne work using machine learning only, without input from SOC analytics?
Yeah, you don't need any input. The agent is pre-trained. Of course, you can do custom rules if you so wish, but there is no configuration or baselining that needs to be done to do the detections. It's out of the box. So from the machine learning part, we use what's called supervised machine learning. So what we're doing is basically when we look at files, we extract attributes from files, stuff that files contain, like is it signed? Does it have debugger functionality? Does it have keylogger functionality? Does it use strange libraries? So it's around 41,000 attributes, I think, right now. So what the machine model learning has done really is extract all the attributes from a set of malicious files and a set of benign files, a few million of each. And then it kind of figure out what is most common to malicious files and what is most common to benign files. And that way it can make a decision that the likelihood that a file is malicious based on how other malicious files are built and what they contain. It's very effective. We say that around 80% of our detections comes pre-execution. That's 100% machine learning. Then the next stage on execution, sure, we use machine learning there too, but much more importantly, we use logics. So things that attackers do on machines when they breach them. So we detect things like privilege escalations, persistence mechanisms, and methods that hackers use on machines. And that way we can detect regardless of what process is executing them. So that gives us the ability to protect against fileless attacks, for example, but also live over the land attacks that only use Windows internal stuff. Most hackers today typically don't use malware. They usually use PowerShell, basically, to breach machines. And most often through Excel documents or Word documents with macros. Did that make sense?
Yeah, very interesting. One more question. Can SentinelOne work on-prem only? I suppose such was the question, because Judith answered that it works on cloud as well, but
yeah,
it can work on-prem.
Yeah, absolutely. We have an on-prem solution. There are limitations. Like the threat hunting part of SentinelOne, when you do incident response or threat hunting, that needs to be cloud because the data is immense. So we need that big AWS infrastructure. But in those cases where you have those requirements, you can always use a hybrid mode, which means that the management console and all the configuration is on premise, and you decide what data to send to your AWS bucket that you can later ingest and search for. So there is basically three solutions. It's cloud, it's on-prem, and it's hybrid. But everything we saw today here, that you can definitely run on-premise.
Okay.
So I can ask a question for you. So how can we get the files back if they were encrypted and deleted? So we kind of cheat here. So Windows takes snapshots of files all the time, natively by the operating system. So instead of building something on our own to do this kind of remediation feature, we use the Windows shadow copy service to do this. And the way we do it is by protecting shadow copies. So no process, or regardless if you're an administrator, system admin, or a malicious attacker, you can't delete the shadow copies from the machines. So SentinelOne does not add any overhead at all to the machine by having this feature. It's basically built into Windows and is running in the default configuration from Windows 7 and forward. It's an elegant solution.
Okay.
Good stuff. So how long does it take really to do these kind of things? Like if your policy was set to kill quarantine, for example, you wouldn't need to do remediate and rollback because it would be blocked much earlier. So if you look at the audit trails here from the incident, we can actually see that we killed 61 processes here. And that took less than 100 milliseconds. So 1/10 of a second or less to kill all the processes. Quarantining the offending files took less than 1/10 of a second also. One file was not found, and that's the freebeer.exe because it was deleted by the malware itself before. We remediated the 2,575 encrypted files and anything else created by this malware. That took 2 seconds. And to get back to the state the machine had before it attack, in total took less than 6 seconds. So from fully ransomware back to production in less than 6 seconds, even if we actually let it happen. If our policy would have been set to kill quarantine, as this was an on-write detection, it would have been stopped before executing on the machine at all.
Okay. So one more question, how the proof of concept process looks like? Is it possible in general?
Absolutely. We never charge for a proof of concept. There is no money involved there. So we spin up a console for you guys. The only infrastructure you need yourself is basically endpoints to install the agents on. We typically don't do on-prem POCs unless they are very big. So we much prefer to do the POC process in cloud. It's the exact same console. It's the exact same code that you're going to run on your own machine. Anyway, so there is no difference in like how it feels to work with or responsiveness or anything like that. It's basically because it's much more streamlined to do a PCP, a proof of concept in cloud. It's much simpler to us than having to deploy software and get hardware and virtual machines and so on. But there is no cost involved. Typically, a POC can run up to 30 days. Enterprise POCs on really large accounts can, of course, be much longer. The last one I did for a Swedish company with around 80,000 endpoints took like 8 months. So a POC can be long, but I'd say the typical POC is around 30 days if there is some prep work done.
Okay, sounds good. So, inconvenient question. Do you have some problems with integration, or what we should take in mind during implementation?
Yeah, so one thing always, if you're running multiple security tools on the same machines, you might get issues. So the way to solve that is working with exclusions. There is an exclusion catalog within the SentinelOne console, which will show you the applications that you have installed in your machines that you need exclusions for. So for an example, if you're running something like silence at the same time, you're going to need an exclusion. Otherwise, we risk of interfering with each other, which could end up in blue screens and reboots and things like that. So exclusions are really important if you have multiple security tools. Also, since we do advanced security, we do a lot of kernel-based stuff in Windows, and we also inject into processes, which can cause interoperability issues with specific applications. The ones we know about, we already have in the exclusion database. So if you run a SQL server, you just select SQL Server from the exclusions catalog and apply them to where you want them in your environment.
Okay, thank you for advice.
The footprint of the agent isn't that big. It's actually less than Windows Defender that is built in. So on a Windows machine, we typically use somewhere between 150 meg and 250 meg memory at any given time. Very little CPU usage. And that's because we don't have big databases of signatures on the machines. So we're actually quite lean compared to a lot of other endpoint protection systems.
Okay, it's a very important advantage.
Yeah, especially very much so when you look at servers, because they're usually pretty low specified.
Okay, so our time is run out, and I should go to finish our...
I hope you guys liked the demo, all of you watching.
Yeah, it's very good.
Next time there will be a bottle of champagne for the best question.
Yeah.
Okay, we will take it in mind. So thank you for the presenters. I will switch to Lithuania. Ačiū visiems už skirtą laiką ir kviečiam registruotis į kitus mūsų renginius.